Welcome to another deep dive, and this time we're heading to the moon.
Ooh, sounds exciting.
Yeah, we're going to explore how people, over time, went from just, thinking about the moon as this, mythical thing
Right.
to a place we could, map out and actually picture, a place you could actually go to.
Huh.
Our main source for this deep dive is Danny Robbins, a history teacher who also writes on his blog, Inbuilding Vision, about, the history of science, technology, and exploration.
Sounds like he knows his stuff.
Oh, yeah. So how much do you think our view of the moon has changed over time?
Oh man, drastically. Like we used to see it as a, some kind of god.
Right, right.
To now like a celestial body we can, map and study. It's pretty amazing.
Yeah. And it's not something that just happened, overnight, right?
Oh no, absolutely not. This took centuries. Century of people watching, technology getting better and some really, really groundbreaking scientific discoveries.
Let's start at the beginning. How did, really early civilizations view the moon? Do we know?
Well, think about it. Before we had telescopes and stuff, people just had their eyes.
Yeah.
So ancient civilizations like the Egyptians,
Right.
the Babylonians, they were fascinated by the moon, how it moved. They would track its phases and when it would, eclipse and its position, like with the stars.
So they were paying attention, but did they really understand what it was?
Not really, not like we do now. They just kind of put the moon into their myths and religions.
Mhm.
For example, the ancient Egyptians, they thought about the moon like it was Thoth, the god of wisdom and writing.
Oh, interesting.
Yeah, and then the Babylonians, they linked it to Sin, who was their moon god.
Oh, wow. So it was woven into their entire worldview.
Exactly.
And they were kind of setting the stage by just, constantly watching it and writing down all the patterns and stuff.
Oh, for sure. That kind of careful observation, that's like the whole foundation of science. But it wasn't really until the ancient Greeks that we started seeing a more, like a real system.
Okay, so the Greeks.
Yeah.
And when I think of the Greeks, I always think of Aristotle.
Oh, of course.
What was his view of the moon?
Well, Aristotle, he believed that the Earth was at the center of the universe.
Right, right.
And everything revolved around us.
Okay.
He thought the heavens were made of this perfect, unchanging substance called aether.
Huh.
And the moon was stuck in this celestial sphere, also made up of this ether.
So it was part of this, untouchable world.
Yeah, you couldn't, visit it, not if you were a human.
Yeah, yeah.
And honestly, this Aristotelian view, it's stuck around in the West for centuries.
A long time. Okay, so we've got ancient cultures worshiping it, and then Aristotle making it this distant, perfect object.
Yeah.
What was it that changed this view? Was it the telescope?
Oh, 100%. The telescope, it was a game changer. When it was invented, in the early 1600s,
Right.
astronomers, guys like Johannes Kepler, Galileo, they could finally see the moon in more detail than ever before.
They pointed it up there, and what did they say?
Oh, well, it wasn't this perfect, flawless thing anymore. Like Galileo, he made super detailed drawings, of the surface, showing mountains and craters and just these massive plains. And, it wasn't the smooth sphere anymore.
Oh, wow.
It was rugged and just dynamic.
That must have been a wild moment, realizing it was completely different than what people thought for centuries.
Oh, yeah.
Do you know, did people even accept that?
Well, some people really didn't. They held on to those old Aristotelian ideas.
Right.
But, I mean, you can't deny evidence, right?
Yeah, it's right there.
Exactly. The telescope had shown the truth, and after that, it was like a boom of new lunar observations and theories.
It seems like things really accelerated after that.
Yeah.
Robbins mentions this term placemaking.
Oh, yeah.
What exactly does that mean?
That's a really interesting idea. It's basically when scientists and astronomers started, mapping and naming and visualizing stuff in space.
Okay.
To make it feel more, relatable, like a place you could actually imagine going to.
Right.
It's like those old explorers making maps of new continents here,
Yeah.
making it familiar. So they wanted to make the moon relatable, something we could actually understand and maybe even explore.
Yeah, you could picture yourself going there.
Exactly. Like a great example, Giovanni Battista Riccioli, this Jesuit priest in the 17th century, he made a super detailed moon map. And he gave a lot of those features the Latin names we still use today.
Oh, wow.
Like Mare Imbrium, Sea of Rains, and Mare Tranquillitatis, the Sea of Tranquility.
I love those names. They're so cool. And they really do make you think about it as a landscape.
Yeah, and that's what Riccioli wanted to do, make it feel familiar and spark that sense of wonder. His work was huge in changing how we saw the moon. It went from this distant object to a place that felt, a bit more like Earth.
This is super interesting.
Right.
So the telescope helped us like actually see the moon,
Yeah,
and then people like Riccioli helped us, picture it as a real place.
exactly.
What was like the next step? What happened next?
Well, the next big thing was detailed lunar mapping.
Maps. Okay, that makes sense, right. Maps are all about making a place knowable.
Absolutely.
Tell me about, like, who were some of these early map makers?
Well, one of the first was Thomas Harriot, an English scientist. You know what? He actually looked at the moon with a telescope before Galileo.
Oh, really?
Yeah, he made these map-like drawings, but they weren't as detailed as Galileo's.
So he was first, but Galileo got more detail.
Pretty much. But Harriot's work was still, like, mind-blowing at the time.
Yeah, it was still early on.
And then there was Johann Tobias Meyer, this German astronomer and mathematician. Man, he took moon mapping to a whole other level of accuracy. Like, he made a whole grid system,
Oh, wow.
and his measurements were super precise.
Oh.
Yeah, they were so good that astronomers used them for decades.
Oh, wow.
And honestly, they were crucial for planning those later lunar missions.
I bet. But weren't they still, like, held back by the technology, right? Telescopes could only see so much.
Yeah, for sure. Even with Mayer's crazy maps, we were still missing pieces. You know, Robbins talks about the story of Johann Krieger.
Okay.
He was a German astronomer,
Uh-huh.
and he took photographs of the moon,
Okay.
but then he would draw in all the missing details by hand. He was trying to create this, like, perfect, complete picture of the surface.
Oh, like he was filling in the blanks.
Totally. It's kind of like when an artist, restores a damaged painting or something.
Right, right.
And it's interesting, he was using photographs. Like, when did photography even start to be a thing for looking at the moon? Oh, photography, it really came into its own in the 19th century.
Yeah, that makes sense.
Suddenly, we could capture these, like, super high-res images,
Right.
which means even more accurate and, like, full maps.
So we had those early maps from telescopes, and then photography came in and just, like, revolutionized everything.
Totally, totally. And as photography got better and better, our understanding of the moon just exploded, too. Scientists could finally look at all the features in detail, analyze the craters, the mountains, and even start thinking about, how it all formed or its geological history.
Right. So we're going from just seeing it to actually trying to figure out how it got there.
Exactly, exactly.
That's a big step.
It is, and it really sets the stage for the next phase of lunar exploration. Like, what are these craters and mountains actually made of? How old are they?
Right.
What can they tell us about, the history of the whole solar system?
That's a perfect place to pause because that sounds like a story for the next part of our deep dive.
Yeah, for sure.
So we started by seeing the moon as like a god, that it was this perfect sphere. And now it's a world with all these unique features. We've mapped it, named everything, and now we're starting to think about its geology.
Yeah.
It's amazing how much our understanding has changed, in just a few centuries.
It really is, and this is just the beginning. Next time, we're going to get into how robots and the Apollo program really turned the moon from this mysterious place into a place of, scientific exploration.
Okay, I can't wait to hear about that. And for our listeners, we'll pick up this lunar journey in the next part. Until then, remember to like, subscribe, and leave us a comment telling us, what surprised you the most about how we came to see the moon differently.
Last time we talked about, how our view of the moon changed from this mythical thing to a place we could actually map and study.
Right, right.
But even with all that, there was still this big question.
Uh-huh.
Like, how did those lunar craters actually form? Like, were they volcanoes or something else entirely?
It's interesting that question stuck around for so long, even with all those detailed maps they were making.
Yeah.
What were the main theories back then?
Well, a lot of scientists in the 19th century, they thought the craters were volcano.
Okay.
I mean, volcanoes, we see them on F, right?
Yeah, yeah.
It kind of made sense.
Yeah.
But some people weren't so sure, like this geologist named Grove Carl Gilbert.
Gilbert. Wasn't he the one who came up with the impact theory, the idea that, asteroids or comets smashed into the moon and made the craters?
Yeah, that's the one. Back in 1893, he actually presented a whole paper arguing that the craters, like their shape and how they were spread out, it all pointed to impacts, not volcanoes.
Huh.
But most people didn't buy it back then.
Why not? What kind of evidence did he have?
Well, Gilbert, he looked at all those craters and he noticed that they were almost all circular. And he was like, if these were from volcanoes, wouldn't they be different shapes?
Yeah, that makes sense.
Right, like volcanoes on Earth, they make all kinds of crazy shapes.
Yeah.
And he also pointed out that a lot of the lunar craters, they had these raised rims and like ejected blankets.
Okay.
That's the stuff that gets blasted out when something hits.
Right, from the impact.
Exactly. And you don't really see that with volcanic craters.
So his reasoning, seems pretty straightforward.
Yeah.
Why didn't it catch on?
Well, scientific ideas that they don't always, spread quickly, especially when they challenge what everyone believes.
Right.
And Gilbert's theory, it was missing one big piece.
Okay.
He couldn't find any impact craters here on Earth to actually study up close.
Ah, so no craters on Earth, no proof.
Pretty much. So the impact theory, it kind of just sat there for a while.
So how did it finally become, accepted?
Well, it took a few decades, and another brilliant scientist, Ralph Baldwin. In the 1940s, he was working on this project for the military. They were studying the craters made by bombs and artillery shells.
So like man-made impact craters.
Exactly. And Baldwin, he was really meticulous. He measured everything, the shape, the size, how they were spread out.
Yeah.
And guess what? He realized they looked a lot like the craters on the moon.
Oh, wow. He must have had a real aha moment.
I bet it all just clicked. Based on his observations and all those calculations, Baldwin came to the same conclusion as Gilbert. Those lunar craters, they were mostly from impacts, not volcanoes.
Huh.
He wrote it all down in a book called The Face of the Moon in 1949.
Okay.
And that book, it basically became like the Bible of lunar science.
So Gilbert, he laid the foundation, and then Baldwin comes along and puts in the missing piece.
Yep.
But something tells me there's more to this story. Danny Robbins talks about the Cold War.
Uh-huh.
What role did that play in all this?
Well, the Cold War, it might sound strange, but it actually played a big role in our understanding of the moon. You see, that space race between the U.S. and the Soviet Union, it created this urgency.
Right.
And suddenly there was all this money being poured into space exploration.
Right, because launching rockets and putting up satellites, it was like a way to show off who had the better technology.
Exactly. And some scientists, like this chemist named Harold Urey, they saw this as a chance.
Okay.
They argued that, hey, exploring the moon, it wasn't just about beating the Soviets. It could be really valuable for science.
Right, yeah.
Like studying the moon, it could teach us about, the early days of the solar system, how planets form, maybe even about the history of our own Earth.
Wow. So this Cold War rivalry, it was definitely a tense time, but it also kind of pushed lunar science forward.
Totally. And it led to all these robotic missions like Ranger, Surveyor, and those Soviet Luna probes.
Okay, robots on the moon.
Yep.
Tell me more about these missions.
Well, Ranger, those were basically kamikaze spacecraft.
What?
Yeah, they were designed to just crash into the moon.
Really?
But before they did, they had these cameras that sent back close-up pictures.
Wow, that's a pretty dramatic way to gather information.
It is, but most of them worked.
Okay,
They gave us a lot of info about the moon's surface, helped scientists understand the landscape better.
cool. And what about Surveyor? What was its mission?
Surveyor was designed to actually land softly on the moon.
Okay.
They had all these instruments on board, things that could analyze the soil.
Huh.
So we were finally getting, real ground truth about the moon, not just pictures from far away.
That's a big step.
It was. Surveyor confirmed that the moon's surface was covered in this layer of dust and rocks, what they call regolith.
Okay.
And maybe even more importantly, they showed that we could actually land a spacecraft safely on the moon.
Right, which paved the way for human missions.
Exactly. And then there were the Soviet Luna missions. Those were crazy ambitious for their time.
Yeah, what did the Luna probes do?
Oh, they did a lot of firsts. Luna 2 was the first spacecraft to actually hit the moon, and Luna 3, that one sent back the very first pictures of the far side of the moon, the side we never see from Earth.
Oh, wow.
Yeah, that was huge. They also tried soft landings. Luna 9 was the first spacecraft to actually land softly on the moon back in 1966.
Wow.
And Luna 10, that became the first spacecraft to orbit the moon.
The Soviets were really leading the way in those early days of robotic exploration.
They were, and all those robotic missions, both American and Soviet, they were super important.
Yeah.
They gave us so much data. It helped confirm that impact theory, refine our understanding of lunar geology, and they started to help us plan for the ultimate goal, sending people to the moon.
And that, of course, leads us to the Apollo program.
Yep.
It sounds like those robots, they were the key to making that giant leap happen.
They really were. Next time, we'll dive into the Apollo missions and how they changed everything, how we went from seeing the moon as this distant object to a place where people could walk, explore, and do actual science.
We've come a long way, hasn't we? From like those ancient myths to these super detailed maps.
We have.
From the first telescopes to actually like landing robots on the moon.
It's
And now we're at like this huge moment, the Apollo program. It wasn't just about, sticking a flag in the ground. It was about like really pushing what we could do in space and, understanding the moon even better.
Absolutely. It was a moment that captivated the whole world and really launched a whole new era of exploring the moon.
But before we get into Apollo, we got to talk about Lunar Orbiter. What was it like its whole purpose?
Oh, Lunar Orbiter was a whole series of missions with robots. They basically paved the way for those Apollo landings.
Okay.
These spacecraft, they orbited the moon, taking super detailed pictures, mapping everything out, basically scouting for the perfect landing spots for the Apollo missions.
So they were like the advanced team, making sure it was safe for people to land there.
Exactly. That's a good way to put it. They gave NASA these amazing images so they could pick these nice, smooth, safe areas for the lunar modules to touch down.
And that's where this geologist, Farouk Elbaz, comes in, right?
Yeah, Robbins talks about him in his blog. Elbaz, he was crucial in analyzing those lunar orbiter images.
Okay.
Like, he really studied the lunar landscape, looking for, safe zones and areas that would be, like, scientifically interesting for the astronauts. He even trained the Apollo astronauts using those images to, like, familiarize them with the terrain.
Wow, so he was like the bridge between robots and humans.
Exactly. It shows you how, scientific knowledge and technology, they got to work together to reach these big goals.
It's crazy to think those astronauts were guided by, some geologist looking at pictures from a robot orbiting the moon.
I know, right?
Okay, so we've got the stage set. Lunar Orbiter did its job. They picked landing sites. The Apollo astronauts are, like, ready to go. What were the main scientific goals for those Apollo missions?
Oh, the Apollo missions, they were about so many things, but science, that was at the heart of it all.
Right.
Their biggest goal, to collect samples, rocks, and soil from the moon
Okay.
and bring it all back to Earth to study.
Why was that so important?
Well, think about it.
Yeah.
Those samples could tell us so much more than pickers or what robots could analyze. We're talking the moon's composition, how old it is, what processes shaped its surface.
Right.
Scientists could study the minerals in the rocks, their isotopic signatures, even look for signs of water or, other volatiles
Okay.
that help them figure out how the moon formed, its volcanic history, and, its whole relationship with Earth.
Sounds like a gold mine of information.
It was, and honestly, we're still learning from those samples today.
Oh, wow.
Scientists are using, new techniques all the time to unlock even more secrets.
So collecting samples was like the main thing, but did they do any other science experiments on the moon?
Oh, yeah, tons. The Apollo missions, they brought a whole bunch of scientific instruments to the moon.
Okay.
They set up seismometers, to study moonquakes.
Uh-huh.
They had laser reflectors to measure the distance between Earth and the moon with crazy accuracy. They even had a solar wind experiment to study all those charged particles coming from the sun.
It's like they built a whole lab up there.
It was, and all that data, it's been crucial not just for understanding the moon, but for understanding the whole solar system, even the history of the sun.
Wow. So Apollo, it was a huge achievement, not just for putting people on the moon, but for lunar science, too.
Absolutely. It completely changed how we saw the moon. It went from this, far away, mysterious object to a world we could actually study up close.
Right.
A world that could teach us about Earth and how the solar system evolved.
So what happened after Apollo? Did we just, stop going to the moon?
Oh, no, not at all. While the Apollo missions were like the end of that space race and, sending people to the moon, we never stopped exploring with robots.
Right.
We had missions like Clementine and Lunar Prospector in the 90s, and then even more recently, the Lunar Reconnaissance Orbiter and Chandrayaan-1.
And these missions, they were, building on what Apollo started, getting even more data about the moon.
Exactly. They helped make even better maps, found potential resources like water ice at the poles, even studied the moon's, super thin atmosphere.
It seems like we can learning more and more about our little neighbor up there.
We do.
What's next for lunar exploration?
The future. Oh, it's super exciting. We're seeing this renewed interest in sending people back to the moon.
Okay.
Programs like Artemis, they want to actually build a base there, make it a place where we can, stay for a while.
Wow.
Not just flags and footprints this time.
A whole base.
Yeah, a place for research, maybe even using resources from the moon, and a stepping stone for going even further, like Mars.
Sounds like science fiction is becoming reality.
I know, right? And all of this, it's built on the work of those early astronomers, the map makers, those robotic explorers, and of course the Apollo astronauts. They dared to dream of reaching the moon. And by doing that, they opened up this whole new world of, scientific discoveries and what humans can achieve.
It's such an amazing story. Human curiosity, ingenuity, and working together. We've covered so much in this deep dive. It's mind-blowing how we went from seeing the moon as this, distant, mysterious thing to a place we can study up close, explore, maybe even live on one day.
And who knows what we'll discover next. There are still so many mysteries out there waiting to be solved.
It's a really exciting time to be following lunar exploration. A huge thank you to Danny Robbins and his blog Inverting Vision for inspiring this deep dive.
Definitely check out his blog. We'll put a link in the show notes.
And to our listeners, we want to hear what you think. What part of the moon's story really stood out to you?
Yeah, leave us a comment with your thoughts and questions.
And don't forget to like and subscribe to stay tuned for our next deep dives into, all those fascinating corners of knowledge and exploration. Until next time, keep looking up and keep exploring.